In this video tutorial, you will learn about the storage options supported by Milestone XProtect VMS. Milestone supports several different options for storing recorded video. Although certain storage technologies are better adapted for use in a short-term live video database, and others for long-term archived video. We'll classify storage into the following types: direct attached storage, storage area network, indirect attached storage. Let's take a closer look at these. Milestone requires the use of direct attached storage for the recording of video to the live database. Direct attached storage is recommended to ensure a reliable connection and high write speeds, resulting in high video database integrity. The types of direct attached storage usable within the Milestone VMS include anything from local hard disks to an entire storage area network, or SAN, which is attached to the recording server with a fiber optic data link. SANs are mostly accessed through the network using connection technologies such as iSCSI, or Internet Small Computer Systems Interface, a virtual SCSI connection. The other classification of storage is indirect attached storage. It can be thought of as external storage, such as network attached storage or USB drives. These storage technologies are typically larger in total volume and resemble file servers. Indirect storage devices are also less responsive than direct attached. Therefore, they are not a suitable choice for live databases. Indirect attached storage can consist of any combination of hard disks and added redundancy measures. It is often desirable to use network attached storage for archived databases to ensure data security and reduce cost. Milestone highly recommends that video databases not be located on the same disk as the server's operating system, since this also will reduce write throughput and potentially compromise video integrity. In XProtect video management systems, each individual camera creates its own video database. Therefore, Milestone recommended distributing video device streams across as many different disk storage locations as possible to improve aggregate write throughput for the system. The more distributed the storage of the camera streams is, the higher the aggregate rate of throughput the system will be able to support. Writing to several or many disks instead of one or few will allow your XProtect system to be able to support more cameras, more clients streaming live and recorded video, and higher quality video streams. Just a bunch of disks, JBOD, is the technology in most desktop computers, where drive letters such as C, D, E, and F are commonly seen. Redundant array of independent or inexpensive disks treats several hard disks as one logical unit in order to increase data redundancy, performance, or both. Some key terms to understand when talking about RAID are striping and mirroring. Data striping is the spreading of sequential and random blocks of data over multiple disks. Data mirroring involves writing the same data to multiple disks. Different types of RAID arrays have different characteristics that make them suitable for different purposes. RAID 0 involves striping data across several disks, 2 at a minimum. It is faster than JBOD. Its drawback is that it's less secure, even than JBOD. Because the data is spread in chunks across multiple disks, we risk losing all the data if one disk becomes corrupted. Since if we lose even part of the data, we are unable to reconstruct the original. RAID 1 involves mirroring data on more than one disk. This adds a level of redundancy to the data, making it more secure, but also more expensive. Since all data is duplicated, it essentially cuts the available disk space in half, making the cost per megabyte of data higher. RAID 1 requires a minimum of 2 disks. RAID 10 involves both striping data across several disks and mirroring the data at the same time. It requires a minimum of 4 disks, but provides the best of both worlds, the speed of striping and the redundancy of mirroring. RAID 5 is a more advanced technology. It generates a parity bit per stripe for added security. Parity bits are used as the simplest form of error detecting code. In case of disk failure for a RAID 5 system, the lost data can be replicated on a replacement disk. RAID 6 generates 2 parity bits per stripe, further enhancing the redundancy added by RAID 5 by providing double disk failure redundancy with a slight increase in computing overhead. Each storage type listed here has characteristics that make it appropriate for a given purpose. Now that you know how different storage technologies operate, let's take a look at what Milestone recommends for storage choices. For XProtect to function optimally, you must select the appropriate storage type for the intended storage purpose. For tight budgets, JBOD provides the best compromise for performance, cost, and data security. For an optimally designed system, however, here's what Milestone recommends. The Windows operating system should be installed on a RAID 1 configuration to ensure full data redundancy. The camera's live databases should be kept on a RAID 10 configuration. It is also possible to utilize a RAID 5 configuration for the live database, as long as the I/O performance is present at all times, including when the RAID is rebuilding after a disk failure. The camera's archive databases should be on a RAID 5 configuration to ensure full redundancy with good economy. You just learned about the different storage options supported by Milestone XProtect VMS.